Hello my dear students, welcome to our program for science third prep stage. Today we have another session about speed, velocity, acceleration, and we have many applications for all of them. Let's start our session today and concentrate with me very well. Let's start. So we have the velocity and acceleration also. So the meaning of velocity and the difference between velocity and acceleration. So we have an example to calculate the acceleration, to know about the acceleration or the meaning of acceleration here. Racing car accelerate from rest to speed from 60 meters per second in a time of 4 seconds. So what is the acceleration of the car? It's very easy. We have speed and we have the time. So here the answer will be like this. We have the acceleration will change in speed, divide the time taken. So 60 meters per second divide 4 seconds equal 15 meters per second square. It's very easy. From the triangle, from the rule, from any one of them, acceleration A equal V divide T. Acceleration equal change in speed divide the time taken. After that, we have another one about the acceleration and velocity and the speed. The meaning of velocity here, it is the change of displacement in unit time. Again, it is the change of displacement in unit time. Mister, the meaning of displacement here, it is a distance. Wrong. Why? Because the distance is the actual path of what? Of the moving body. That change its point from the starting point to the end point. So the displacement is completely different. What's meant by displacement? Here we have the meaning of velocity first, or it's the rate of change in displacement. What's meant by rate here? I erase unit time here, so the meaning of the word rate, it means a change in time, change in unit time. So here we have two definitions. Velocity, it means what? It means the change of displacement in unit time. Or we have another one. It is the rate of a change in displacement. Rate, it means a change in unit time. So after that, we have this one, the displacement. What's meant by this one? It's the shortest straight line. Shortest straight line, it means the straight line that covered by the moving body from the starting point to the end point in the shortest line. So it is the shortest line is the straight line. So curved or covered by the moving body from initial or starting and final or end point. Like this, if I move this car from here to here like this, so it means distance. Here it's the displacement because it moved the distance and displacement in one straight line. In this case, just in this case. So starting again, the displacement, it means the shortest straight line that covered by a moving body from initial or starting point or original point and to the final point or end point. After that, we have another part here about displacement and velocity and the difference between distance and displacement. So we have an example here. The distance, again, it is the actual path of the moving body. So we have this example like this. We have a car or the bus. We have our bus here many times. So we have another one. This bus, it moves like this. And we have another distance from here to here. And the other bus or the same bus change here from here, from this point or the second point to what? To the third point. So we have the first one is a distance and the second one is a distance. But I have two distances. What is the displacement? Displacement here, it means what? The shortest straight line that found here. Okay, from what? From the starting point to the end point. Here we have the end point and here we have a starting point. But mister, we have here the end point of the first one. Yes, it's very easy to know this. So the distance here, it's the first distance and the second distance. So the distance here, it means what? It means the actual path that move from starting point to the end point like this. Displacement like this here, it means the shortest straight line from starting point to the end point in one straight line, and it has a direction. What's meant by direction here? Direction, it means from starting point to the end point, directly to the end point. in the straight line. So this is the meaning of each one of them. After that, so the displacement is the shortest straight line for last time. The covered by what? Covered by a moving body from initial or starting point to the final or the end point. And the distance here, distance it means the actual path of the moving body. Actual path it means the actual motion or the actual distance that covered by the body from the starting point to the end point. If I have 10 distances, this is called distance. But the displacement, what is the first point or the starting point to the end point in one straight line in one direction or a definite direction like this. So we have here exercise. We need to rush this quiz and speed and acceleration like this. Start it. What's meant by velocity? Velocity, it means what? It means the measure of an object speed direction, or the measure of an object direction only, or the measure an object speed only, or measure of an object speed or direction. This one is wrong. Why? Because here we have the object speed or direction. No, it's and direction, right? Because I need here the measuring. Measured what? Measure or determine the object speed and its direction in the same time. Next one. How does the gradient of distance time graph represent? It's nothing. No way. We have what does the gradient of distance time graph. Distance time, it means what? It means speed. So the speed of an object may be the distance traveled by an object. No way. The acceleration, no. It's letter B, right? Why? Because here we have distance time. It means what? It means speed. Let's go to see another one. If the gradient of distance time graph is 0. So what does that indicate about? What does this indicate about the object? It's stationary, maybe. It move in the uniform speed, maybe also. It's accelerate, no way, it's wrong. It's impossible to make acceleration. It has the distance time is 0, and either stationary or moving uniform speed, maybe this one. It is wrong. Why? Because we have no uniform speed, because the distance time. So it is as stationary or the body at rests. Next one. What does the acceleration of an object represent? Direction. Again, the question again. We have what does the acceleration of an object represent? Acceleration of object represents what? Represent two things. We have velocity and time. So the direction in which the object moving, or the rate of a change in an object speed. Yes, this is right. Letter C is right. Why? Because rate here, it means a change in time of the speed. So we have the time and speed. It means acceleration here. After that, so we have next one. So the car is acceleration of negative 5 meters per second square. It's very important to know this question. What does this indicate? Negative 5 meters per second square. And we have negative, it means decrease. Meter per second square, it means what? It means the acceleration. So we have decreasing acceleration. It means nothing, letter A, nothing, acceleration can never be negative. No way. The car is traveling at uniform speed. Maybe. And the car is reversing, or the car is decelerating. This one is right. Why? Because we have negative 5 meters per second square. It means deceleration. So deceleration, it means what? It means decreasing acceleration or decreasing the speed during time. After that, you have what does the gradient of speed time graph indicate? Speed time. So this acceleration. So we have what? We have acceleration of an object. Next one. We have the gradient or the slope or the graph of the speed time graph is 0. Speed time graph is 0. What it does indicate? It's accelerating. This is wrong. If there is stationary or moving uniform speed, yes, maybe. Identify the moving speed in uniform speed or identify the stationary. Stationary only is wrong. So we have this one because uniform speed or stationary. So after that, we have another problem like this. It's a train takes 100 seconds to travel 1,500 meters or 1.5 kilometers. So what is the speed of this train? So it is very easy to know this. So after that, this one, speed, it's equal distance divide time, and this one is 1500 divide 100 seconds. So because this is our meters, divide seconds. So here this is 15 meters per second. This is about the speed of this train. Another one, a racing car accelerates from rest. From rest, it means from 0 meter per second. Speed of 60 meters per second in a time of 4 seconds. What is the acceleration of this car? It's very easy to calculate it. Answer is acceleration equal change in speed divide the time taken. So we have 60 divided 4 equal what? Equal 15 meters per second square. Another one, we have calculating the speed problem here. A car travels at 25 meters per second for 3 minutes. What about this? How far this does travel? And calculate the distance. It means how far, it means calculate the distance here. So the answer is V equal delta D divide delta T. It means what? It means the distance divide the time. So distance equal V times T. We have speed times time. So 25 times 180 comes out from 3 minutes. Change it into 180 seconds. So it's equal what? Equals 4,500 meters equal 4.5 kilometer if it needs to change it to what? To kilometer. Now we have another part about what's about the velocity, acceleration, and many things like this. We have different parts here. We have physical quantities. What's meant by quantities? Quantities, it means the concept, the writing or the scientific terms here. Acceleration, time, distance, velocity, force, weight, mass, anything like this. So we have many types of this one, and we have 2 types of these physical quantities. Let's go to see this part of our lesson, and it's very easy. It's very interesting for you. Let's start. So we have physical quantities like this. They are classified into 2 types. 2 types of physical quantities like mass, like force, like energy, like, for example, we have acceleration, speed, distance, and displacement, many things like this. Classified into 2 types. Scalar quantities. It is not a scalar for reading. You have scalar quantities. They are quantities that need magnitude only to be identified. So we have quantities, some or many quantities that needs magnitude. What's meant by magnitude here? Magnitude, it means the value. I need the number. I need the amount of this one without direction, without anything else. I need the number. For example, we have mass. How many kilograms of your body? This is a part. I need to know the kilograms, just kilograms. But I don't need what is the place of your body, or where are you from, or anything like this. So we have this, they are quantities, scalar quantities. They are quantities that need magnitude only to be identified. And we have another part. We have vector quantity. Vector here, it means direction in math. So we have vector, it means they are quantities that need magnitude and direction, both of them, to be identified. We have many examples to make the comparison between them. So we have the examples here of a scalar quantity. We have meter, that meter here, it's measuring unit of length, and we have kilogram, the measuring unit of mass, and we have second, the measuring unit of time, and we have ampere, the electric current, for example. They are, what are the concepts here? Length, mass, time, electric current, anything like this. It needs what? It needs just the value. Meter, how many meters, how many kilograms, how many seconds, how many amperes. I don't need anything else about this. So we have speed, we have distance, we have time. So they are distance like length here. So the length here, it means meter or measured by meter. I need to know how many meters of this length, how many meters of this distance, and so on. But I don't need the direction. This length, it's found in which direction from starting? What is the starting point to the end point? I don't need this. So the length and mass, time, electric current, and so on. We have the speed. It's one of the scalar quantities. And we have another one. We have examples of vector quantities. Vector here, it means velocity, displacement, acceleration. We have weight, force, work, and so on. So the first one, we have velocity. Velocity, it means meter per second. This is the measuring unit of this. But I need the direction because it contains displacement or included displacement. And acceleration, it needs what? It needs the direction, because we have two types of acceleration. We have positive acceleration and we have negative acceleration. So the negative acceleration, it means decreasing and move by decreasing the speed during time. And we have another one like weight. Weight depends on what? Depends on our gravity. So the gravity, it has a direction downward. So it has a direction, so it is one of the vector quantities. The force, according to the moving body, according to the work that done on this body to move or to change its place. So here we have work, force, weight, acceleration, displacement, velocity, and we have many things like this. That example that called vector quantities. It needs what? It needs two things. Number one, we have magnitude or the value of each one of them, and it needs direction of what is the direction of each one of them, from which part to which part, from which point to which point, and so on. Now we have an exercise about what? About the acceleration, change in speed by time. Let's start. So we have many of them. We have a car increases in speed from 10 meters per second to 20 meters per second in 10 seconds. So what is the acceleration? I need to calculate the acceleration here. So we have two speed. Here we have the acceleration, it means v2 minus v1 divide the total time. So we have 20 divide minus 10 divide 10. What's meant by this? We have this one here. Here we have 20 divide or 20 minus 10 equal 10. 10 divide 10 equal what? Equal 1 meter per second square or 0 meter per second square. This is 1 like this because we have 10 divide 10. Why we have 10 divide 10? Because 20 minus 10 divide 10 equal 1 meter per second square. Next, a bike traveling at 30 meters per second slows down. So we have deceleration. So we have negative. Slow down to stop in 15 seconds. What is the acceleration? So we have 30 meters per second divide 15. It's equal to 2 meters per second square meter. No, is wrong. Why? Because we have here slows down. Slows down, it means negative meter per second square. So the change of speed divide the time. 30, negative 30. Divide what? Divide 15. Because we have here 15, it needs what? It is the time without negative. Because the time, it is not negative, it is positive all the time. So we have negative what? Negative 2 meters per second. Next, we have a cyclist that sets off from rest and accelerates at 0.2 meters per second square for 30 seconds. What's his final speed? It's very easy to know this. So we have this is the acceleration equal v2 minus v1 divide the time. So here we have 0.2 times 30 equal what? Equal 0.2 times 30 equal 6. Okay, so we have 6 meters per second or 30 meters per second or 150 meters per second. I need the final speed. Final speed, it means what? It means 6 meters per second. Why? Because the speed equal acceleration times time, and its cyclist set off from rest. It means the word from rest, it means from 0. So we have 60 or 6 meters per second. It's the last one or the final speed. It means Vf or V final or V2. Okay. After that, we have next. we have the space shuttle accelerate at 30 meter per second square. So this is what 30 meter per second is acceleration at liftoff. How long does it take to reach 1,800 meter per second? I need the time here. So here this is 30 and what? And 1,800. So it is what? 1,800. It means what? It means the speed. Divide what? Divide the acceleration. So it's equal what? Equal 4 or 3 or 2. We have what? We have here. This is what? This is the 4 minutes. No way. It's 3 minutes. No way. It's 2 minutes. 1,800 divide 30 equals 60 seconds. It means 1 minute. So here 1,000 divide 30, 0 with 0, and we have 180 divide 3 equals 60, and we have this one is 1 minute. So we have next, we have the car traveling 2 meters per second, accelerate at rate of 0.5 meter per second square for 20 seconds. What is the final speed? The same one. We have here the first speed is what? Is 2 meters per second. And I need to measure the final speed. So 0.5 times 20 equal what? Equal 1. Equal 10. And 10 minus what? Minus 2 equal what? Equal 8. It's wrong. And equal what? Equal. This one is 12. Why? Because 0.5 times 20 equal 10. So the final velocity is 12. Okay, plus it's 12. 10 plus 2 equal what? Equal 12 meters per second. So this is about what? About this exercise. Write scientific term. It's very important for you to find out the meaning of each sentences here. Okay, sentence, it needs one rule or one concept, one scientific term. The first one, the rate of a change in displacement relative to time. So displacement relative to time or relative to time, it means what? It means velocity. Why? Because here we have displacement and what? And relative of time. So we have time and displacement, so we have velocity. If I have distance and time, we have speed. Or if I have speed and time, it means acceleration. Another one, the distance covered in unit time. So this one is very easy. It's speed, right? After that, we have the actual pass. It's the key word here. Actual pass that covered by a moving body. It means what? It means distance. It is not displacement. Why, mister? Because we have the displacement needs the direction. It doesn't need direction, so we have the distance. It doesn't need direction because it is a scalar quantity. Another one, shortest straight line that covered by a moving body in a direction or in one direction or indefinite direction. So the shortest straight line, it means what? It means displacement. Another one, physical quantity that needs magnitude only to be identified. So the physical quantity that needs magnitude only to be identified. Which one? It's a scalar quantity, right? If you need to write scalar physical quantity is right, but don't write just only scalar. It's a scalar. What scalar? What is the scalar? Scalar quantity, scalar physical quantity is right. So the physical quantity that needs magnitude only to be identified, this is a scalar quantity. Physical quantity that needs magnitude and direction to be identified. So it is vector 1, vector quantity. Like what? Like force, like energy, like displacement, like velocity, acceleration, any one of them. So here we have another type of question that calculation of speed. So calculation of speed, how can speed represented? So we have this one, it's the first one here. We have this activity to make what? To make the relation between distance and time. Every time we have different distance and we have different time. So the speedometer that found here in our slide here increases or show us increasing of speed, increasing in time, increasing of distance here during time. So it reaches about 110 meter per second or kilometer per hour. So here meter and seconds. So it reaches what? It reaches 80, 90, first 80, 70, 60, and we have 50, 40, and so on to reach what? To reach 0 or to make the car stop. So we have many distances that covered here. 994 in 50 seconds, and we have another one 994 in 55 seconds, and we have also 994 in 60 seconds. So we have next like this to find out the table or tabulate these parts or tabulate these numbers in distance time cells. So how can the speed represent? The data can be recorded at the shown in the table. Don't forget this. You need the tables, you need graphs, you need many things about the speed and the acceleration or anything like this. Data can also be shown in the graph. What is an advantage of this one? The advantage here, it means what? It means I can draw a graph and with a gradient like this to represent what? To represent the speed. This part or this speed represented by what? By these parts. We have curved line, we have straight line, we have uniform speed, non-uniform speed, to know the relation between them. Dear friends, I hope to enjoy your time with us. You have many things to study. You have many concepts like acceleration, speed, and the types of each one of them. And we have the time. We have different between displacement and distance and everything like this. You have many questions about this unit to study and revise it many times. Let's go to the exercise, to the next session, till we meet again in another session of exercise of Unit 1. Till we meet again, thank you and goodbye everybody.